Have you ever wished you could ask questions like, is Tesla currently overbought? What does Apple's trend look like? Should I be concerned about recent volatility? And instead of spending hours analyzing charts, an AI gives you the answer instantly. Well, I believe that's exactly what we are going to build today. And the best part, everything runs locally on your machine. No cloud APIs, no API cost, no data leaving your computer. Just Python, Streamlit, Ollama, and local LLM. Let's dive in. So, before we really makes our hands ready, let's first understand the architecture. User interface. This is built using Streamlit. The user enters stock ticker, time period, questions for the AI, something like analyze Tesla's current momentum or is Apple worth to buy it. Component 2 is a data collection layer. Once the user submits, the application calls yFinance cloud APIs to get the stock, historical prices, open price, close price, high, low, and volume directly from the yFinance. Now we have a raw market data with us. The next component is the analytics engine. The raw data alone isn't enough, isn't it? This is where the Pandas comes in. Using Pandas, we calculate indicators such as moving average, RSI, daily returns, volatility, trend strength. Now the system understands what the stock is doing, right? Not just its price. And the component 4 is a visualization layer. Plotly converts the stock into a beautiful interactive charts. User can zoom in, pan, explore trends, analyze the movement visually. So now we have both numbers and visuals. Component 5 is the local AI layer. This is the exciting part. Ollama runs a local LLM, maybe Llama, Gemma, or DeepSeek. Everything runs on your own machine. No external API calls, no cloud dependencies. So beautiful, guys, so beautiful. To make our journey easy and simple to understand, I have uploaded the source code to the GitHub repo. Visit the Curious Architect 09. You'll find this project called Ollama Stock Analyzer. So just clone this project, git clone, and paste the URL, just you copy it. After that is done, for development, I encourage always have a VS Code as an editor. Once that is done, open the VS Code and open the cloned project into the VS Code. After that, just follow the README file available in the project. Create a virtual environment for the Python. Then activate the Python virtual environment. Once that is done, install all the dependencies which are required for this project. Once that is done, we need to set a few environment variables like our Ollama localhost and the model names. Copy the example env and rename to .env file. So once that is done, before run the app using a Streamlit, make sure you have Ollama installed in your machine, and you can check whether it's installed or not. If not, very easy steps. Visit the ollama.com and follow the instruction provided there. Once the Ollama is installed, make sure you pull the model, what is required for this application to run. In our use case, we have used QWEN model. Any other model as well works, like Llama models also works for our demo. Make sure you download the required model. Once that is done, start the Ollama service by running Ollama serve. Once that is done, just run the Streamlit, our app. Visit the localhost port, which is printed on the terminal, and you will get the UI required for us to play around with the stocks. Here you will see the we are in this example we're going to compare Apple with a Microsoft, and we'll try to understand which stock performs better and what is the future of it. Right? This is a typical UI. On the left, configuration. You can select stock analysis metrics like period, interval. So once you click on analyze, it's going to take a little while because it's going to connect to the local Ollama, and the Ollama try to analyze. In this, you can see how the comparison graph being generated, and you have a QX comparison, relative momentum, relative valuation, quality, etc., etc., etc. Right? Now, this data makes sense. It can gives a very good overview of how this stock's doing, and subsequently, even you can interact with this data. with your local LLM. So for an example, let's ask which looks more expensive, right? Now, this request being sent to Ollama comes up with a response like human readable response. It says Apple appears more expensive based on the available valuation metrics. Let's ask one more question. Which one is the best to invest? Now it comes up with the answer saying that both Apple and Microsoft have their strengths, but given your modern risk profile, blah 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 blah, it gives this is the demo of stock analysis, which is completely running on your machine. Now let's understand how architecturally this is working. Let's understand the main components of this architecture. The first one is the Streamlit UI layer. This is the presentation layer where we are interacting with stock analyzer. Like we input the stock symbol, change the Ollama models, we tune the risk profiles and so on. If you look at the code, you will see that we are using the Streamlit library APIs like text input, checkbox, and these APIs are helping us to build the UI what we desire. And the second component is the market data layer. And this layer fetches a stock data using the yFinance cloud API. Our agent is connecting to the real-time data and getting the stock history, stock metadata information, what we ask for. And which includes, for example, day high, day low, volume, market cap, P ratio, so on. Third component is the technical indicator engine. And this layer uses the Pandas to calculate indicators. For example, SMA 20, SMA 50. Third component is a snapshot creation. After fetching data and calculating indicators, the app creates a compact JSON like a stock snapshot. This snapshot is important because it becomes the context passed to the Ollama. Instead of sending a large raw datasets to the LLM, the app sends a clean and summarized data for faster and easy processing. Fourth component is a charting layer. Charts are rendered using the Plotly. These are the two main chart types what we have used in our project. The primary stock price chart where we render the candlestick chart. And second one is the comparison chart where we take the, in our case, we took the Apple and Microsoft and we generated the comparison chart. And the fifth component is Ollama integration layer where this layer connects the app to the local LLM. If you look at the code example, you will see we have defined what model to use, what is our Ollama endpoint to process our request. This means the AI analysis runs locally through Ollama. Sixth component is a prompt engineering layer where we have defined the single stock analysis prompt, which gives us the basic summarization of the stock. We have a comparison prompt where the prompt is taken care of comparing the two stocks and generating the analysis. And third prompt is we have used to ask the further questions on the top of the comparison result. The seventh component is the session state architecture. Streamlit reruns the script every time the user interacts with the UI. So we need to store the existing conversation or existing data so that whenever we ask a subsequent question, those data can be used here. Right? If you look at the code snippet, you will see that under the Streamlit session state, we are kind of maintaining some of the important information which is required as for the subsequent processing. For example, chart history. So as we saw the demo and we understand all the code base, how things are laid down in the GitHub, right? Now dig into the workflow, like how this interaction happens behind the scenes. Assume the user asks, is Apple currently showing bullish signals? Here is what happens. The application fetches Apple stock data using yFinance. And in the step 2, Panda calculates the indicator. For example, RSI is 72, 20-day moving average is this, 50-day moving average is that. And in step 3, the application creates a context package, something like, okay, ticker, which is a stock name is Apple, current price trading is 220, RSI is 72, and so on. In step 4, the user question is added. Is Apple currently showing bullish signal? Which is our earlier question. Everything gets combined into a prompt, something like you are a stock analyst, stock information, current price is this, RSI trend is uptrend. User question is Apple currently showing bullish signal? This prompt is sent to Ollama. Ollama forwards it to the local LLM. The LLM analyzes the information and returns something like Apple appears bullish because the short-term moving average above the long-term moving average. However, RSI indicates the stock may be approaching overbought conditions. And that's the answer shown inside a Streamlit. Pretty cool, isn't it? Everything we experimented using our local machine. So let's understand other real enterprise applications. Take the finance. We can build a tool using a same architecture like analyze the market trends, healthcare, analyze patients' records, customer support, analyze tickets, supply chain, analyze logistics data, security, analyze incidents and alerts. The pattern remains the identical. The same architecture we can replicate to solve all those problems. So today, we looked at how local AI stock analyzer work behind the scene, using Streamlit for UI, yFinance for stock data, Pandas for indicators, Plotly for visualization, Ollama for local AI reasoning. And by combining all of them, we created an intelligent application that can answer stock-related questions using real-time data. I believe this is one of the best beginner to intermediate AI project because it teaches a pattern you will use again and again in enterprise AI systems. If you enjoyed this breakdown, hit like, subscribe, and let me know in the comments what AI application should we build locally next. I will see you in the next one.